Yes. Logic. So I think I made a comment on the class meeting page different today that, and I think I made this comment on Tuesday also, that this is not a logic course, so we're not going to like go really deep into all the logic stuff, but we just need what we need, what the kind of logic we need to be able to do math, right? So and so what that really means is like we have sort of mathematical statements. Or really just, you could, any kind of logical statement doesn't necessarily have to be mathematical in nature. But like, you know, for example, 9 is odd. It's a mathematical statement. 9 is prime. Is a mathematical statement, which is a way of saying that not all mathematical statements have to be true. You know, it can be a false statement, but we've already seen statements like for every a in the integers, a times 0 equals 0, right? That's a mathematical statement. And there's other things you can get into, like this sentence is false, which is a fun one to try to wrap your brain around. You guys seen that before? Because if it's true, then it's false. But if it's false, then it's okay. So it's an interesting, I kind of like that one. Yeah, and so right, so like we can assign truth values to these, right? So this one is true if we define what the word odd means. This one is false. This one is true, we proved it, well, at least from assuming some axioms. And you know, maybe it's neither true nor false. It's an interesting question. So mathematical statements can be true or they can be false. There's a little bit of a question of like what true mean, what the words true and false mean. And the book, I noticed just like looking over the book yesterday, like it sidesteps the question and just says, we won't define what these words mean. So I'll just say a couple things, which is like true could mean I guess let's see, could mean derivable from axioms. That's kind of what we did right with the a times 0 equals 0 proof, is that it's like it's something that we can use logic and derive from axioms. There's another sense, it could just mean not false. Which is a little bit of a strange thing to say, but it's like false. There's something I always like kind of stumble on when I start to think about this stuff, or like I still have to like think through a little bit carefully, which is that if you want to demonstrate something false, you just have to like give a counterexample. You know, like for example, every prime is odd. Every prime number is odd. This is false because you can provide a counterexample, right? Because 2 is prime and 2 is not odd. So this is a counterexample. And so the easiest way to show a mathematical statement is false is to provide a counterexample. And if you can't provide a counterexample, well, you don't necessarily want to say it's true yet, right? Because it just means you may not be able to prove it. But there's a weird thing, and we're going to see this in these truth tables we're looking at soon, which is that empty statements with no content are actually considered true. which is like a strange thing to say, but like, so I'll just sort of say something about that. Like, if we can't, so, and I'll give you some examples of this, empty statements. Are considered true. And that's a little bit of a strange thing to say. And I'll have to give you some examples of this. I'm not sure why I'm writing true and false in all caps every single time I write them. It's not like an unusual thing. I'm just doing that. Like, let me give you an example. Like, every time I go to Mars, I am greeted by little green aliens. This is considered an empty statement because I've never been to Mars. So can we say this false? It's only false if it's like again, like false if you can like provide a counterexample. Like, can you show me a time I went to Mars when I was not greeted by little green aliens? I bet you cannot demonstrate to me that I've been to Mars and not met little green aliens, right? So like, it's a kind of like, we don't want to call this false. And so in that kind of thing, it's like the way that logic works, and I'll show you in a second, in a minute, but we don't want to call this false. So we sort of default to true in cases like this. It's a little bit strange, but it makes the logic work. It's not false until I go to Mars and it's not, and I'm not greeted by little green aliens.
Quick question.
Yeah.
In order for something to be true, does it have to follow both of those requirements, both of those definitions of true, or just one?
Oh, you mean up here?
Yeah. And if it has to follow both, then could you derive from axioms that every time you go to Mars, you're greeted with little green aliens?
Well, you could, right. I guess what you would say is like, I meant this more as like an or, not an and. Like, this could mean derivable for axioms, or it could mean not false. Like, which one, and there's just some weird things in math that math works better if you sort of take these sort of empty statements and just kind of like default them to be true. Because if it's derivable from axioms and you're assuming the axioms are true, then the statement we would definitely want to call the statement true. So like, I guess you wouldn't need both. You would just need the first one. I would say you wouldn't necessarily need, if you can get the first one, then you don't really need the second one. In fact, if you did the first one and you also showed it was false some other way, that would mean your logical system was messed up, or like your axioms are messed up. There's something contradictory in your axioms, right? So it's a good point. Like, right, the axioms need to be self-consistent, or else. So maybe in that sense there is an and here. I mean, yeah. I just sort of I wasn't really intending it that way, but it's a good question. Like, and we can easily get into this whole like deeply philosophical discussion about like what is truth and what is false, what is true and what does false mean. But yeah, I'll show you some more examples to like. And when we look at the truth table for implies, the implication symbol especially, like it's going to be kind of interesting. It's going to be kind of be the right thing, but it's always, I always have a little bit of trouble like explaining why, because it's not intuitive, right?